heating, either salt does raise the boiling point, right, meaning water's going to boil slower, or it doesn't, meaning it might keep it the same and therefore it wouldn't boil faster or slower. Ooh, I misspoke there. So we're either boiling faster or boiling slower depending on the salt's added. Who's cooked with salt in their water before? Raise your hand. Raise your hand. I always put salt in my water, right? So we hear it makes it taste better. We hear it might speed up the process. So what we're looking at here, we just read an article kind of taking it a step deeper saying, does this really have an effect? Something that we've heard about a lot. We want to know if it really has an effect. So we saw two sides of the argument with a little science on each side. And now we have to decide what we think. And then obviously we're going to test it, right? Because I promised you guys another experiment. I'll never go back on my word. So we have to test it. We're going to test it. Rashawn.
So does it have to be like a normal stove, or like, because usually, like, because noodles is pasta, I make noodles in the microwave and I'll put the seasoning and everything in there. So like when it's done, you can just sort of eat it, and it does.
You think it goes faster in the microwave?
When I put the salt.
When you put the salt in. Yeah, that would be the same, right? Because you're still heating up the water. It would still be boiling faster if this is true, right? Could also be true, Rashawn, that our whole lives we have been wrong. And why, when we're putting salt in that water, right, to make it taste good, to make it boil faster, it's actually boiling slower. And we read a little bit about that argument too, right? So this is like Mythbusters. We're Mythbusters today. Have you guys seen Mythbusters? Right, it's really good. We're going to watch some clips of Mythbusters in a few days, but for now, we're the Mythbusters. All right. What were some key observations? What's a big thing you pulled from that reading?
Adam, what do you think? What did you get out of that reading?
I want to know, well, because it's actually it says when salt is dissolved in water, it's no longer considered pure water. It's not pure water anymore because it's a salt in it.
Salt's in it. And what happens, what did it say? So one is that when you put salt in, no longer pure, right?
So write that down as an observation.
And what happens, what does it say happens as a result of putting salt in that is no longer pure? And please excuse my handwriting. What happens, Adam, as a result of it going in? What happens to the water? What happens to boiling?
It lowers the boiling point.
It lowers the boiling point? Does everyone agree with that, based on your reading? Which paragraph is that in, Adam?
It's this paragraph.
So it says lowers the boiling point. That's what you said, right? And the confusing thing about lowering the boiling point is, if I lower the boiling point, does my water boil faster or slower?
Slower.
If I lower the boiling point, is it going to, so if it boils at, do you remember what it said is the boiling point of water? 212 Fahrenheit, or on our thermometers, 100 degrees Celsius. So if I put in salt water and it lowers the temperature, if it goes down, is it going to boil faster or slower? It's going to boil faster, right? So I'm lowering the boiling temperature so that if I'm cooking, it actually is going to boil quicker. So salt no longer pure, boiling point lower. But it boils, it becomes boiling faster. Okay? What was the other main point we got out of this article? Angel.
After that, I'm talking things to water.
I beg your pardon, I'm sorry.
That adding salt can do many things to water.
It can do many things to water. What's an example for you? So it raises the boiling point. Again, we've got that. Anything else that we learned? That paragraph basically said it changes the makeup of water and it's going to lower the boiling point. Marcus?
It disrupts the water molecule.
So it changes the water molecule. It actually changes the water. It's water, but it's no longer pure, right? Anything else? What happens in the second paragraph about where the other argument is? We've got one argument that says the boiling point is lower. What's the other argument that we have on that paper? Matthew?
So the pasta absorbs the salt and makes it taste better.
So that's another thing that happens. We believe that the pasta absorbs the salt and it cooks faster and doesn't stick together, right? Caleb, what you got? It dissolves in the water, and it changes the water. What about so we've got one that says the boiling point becomes lower. What's the other argument? What would be the counter argument? What would be the opposite argument? Come on. So the other argument is, one argument is you put salt in, the water is no longer pure, the boiling point is lower. The other argument is, Lavance, can you say that again? The boiling point is higher. When salt is added.
So does that mean it's boiling faster or slower then? If we have to get to a higher temperature before it can boil? Lavon, what do you think? Yeah, because it takes longer to get up to that higher temperature.
If you're like me at home, I crank my heat up to high, right? So that might not be totally true, but it depends on your heat source, right? How quickly it's going to boil. But it boils slower, it takes longer. Again, what is the boiling point of water, pure water? Larry, do you remember what the boiling point of water would be?
It's in the second paragraph. Or no. The paragraph that says lowering the boiling point. First sentence in that paragraph.
Well, Larry's looking, the rest of you guys could be looking too. That's all I'm doing. Larry's not alone here. Raise your hands when you found the boiling point of water. Larry, what is the boiling point?
It's 212 Fahrenheit.
So 212 degrees Fahrenheit. I just want to put that up there. So pure water boils 212 degrees Fahrenheit. Now in science, do we use Fahrenheit?
No.
Do you know why we don't use Fahrenheit? I think it's because the numbers are too big, mostly, right? It's easier and they're uneven.
Yeah, Fahrenheit's just kind of one of those things. America uses it because America's kind of weird and we're a little different. And we do a lot of things that are different from the rest of the world because we feel like it. Fahrenheit's one of those things. So it's not quite scientific in how the steps in between it and the numbers that we're using. The rest of the world uses Celsius. Celsius is what we use in science. So that's what we use in this class, obviously, because we know we're scientists.
And they have more clear benchmarks, right? So that freezing in Celsius is 0, whereas with us it's 32 degrees Fahrenheit. So it's harder to work with.
Yeah,
Okay, so what is the other, so in Celsius, in science language, or degrees, Marcus, what is our? 100 degrees Celsius.
And so 100 and 0 sound a lot better than 32 and 212. Should be Fahrenheit.
Okay. So with your partners, you can have a conversation in a second about what you think. Circle the appropriate word to fill in the blank. If both fresh and salt water are boiled, then blank will boil first. So circle one, and then talk to your partner about which one you think is true. So talk about why you think it's true, and then we'll come back for your answers. And I'm going to give you about 2 minutes to talk to each other. we should be talking. You actually are allowed to talk to each other. And what you want to do is figure out, which one do you think? Based on the information you've read, or just a hunch? But you have to be able to come up with a because.
I think freshwater.
Freshwater? You think that the salt that we're adding to our cost is actually making it take longer? Nice. No?
Yeah,
Faster? What do you think?
yeah, I think freshwater will make it
Okay. So you think freshwater will then boil first? You have the two. All right. So we've been doing it wrong then. I like that.
This year, salt, the water molecules will like disrupt. If you add too much salt, I would say salt water
Yeah, that's what I thought.
But now you think fresh? I like this. You have a nice little debate here, right? Okay.
But in the article it said that the water molecules evolve into that salt. So therefore, salt water will boil faster than water molecules.
Because salt boils better. Because salt has.
You think?
I thought salt water.
All right, you want to change it to salt water?
You're almost making a claim.
Cool. We have arguments for either here, right? You're right, it does say it could lower the boiling point by disrupting. We also have one for raising the boiling point down here. So I think you could argue either way. But salt water sounds like a good bet. Salt crush? Ooh, I like that. Okay.
Okay, we're going to bring it back together in about 10 seconds. Okay, we're back facing the front in 3, 2, 1. Okay, so what did we come up with? What did our teams come up with? Is salt going to, fresh water going to boil faster or salt water? Louis, what did your guys decide?
At first, me and my partner were debating about fresh water and salt water, but we came to the conclusion that salt water will boil faster. Because in the article it said that if you add salt, it will disrupt the fresh water molecules. So like the salt water will boil faster because there's not enough fresh molecules on the water.
Okay, so you decided salt water, and your reasoning, or your because, is because of the salt water being changed and no longer being pure. Okay? Anybody else? Miele and Carlos, what did you guys come up with?
On salt water.
And why?
Because when you add the salt, it disrupts the water molecules and it makes the bonds weaker so that it goes faster.
So you agree with Louis and Maria. Anybody else? Christian, what do you think? Your team, you and Jose.
Salt water.
Salt water, because? Your copy, they got the same answer as you? Okay. All right, did anybody say fresh water? Because there's two arguments here, right? One argument is it's definitely salt water, and it's because it changes the purity of water. And then there's another argument. And go ahead. Carlos, what's your team? You and Larry come up with?
He said salt, I said fresh.
Okay, so why did you say fresh? So we had disagreements in our teams, right?
Yeah.
So what did you say?
I put fresh because I don't think that I don't know, I just think that fresh water will go faster.
Okay.
I asked my mom, she said fresh.
And moms are always right, right?
Yeah.
All right, so his evidence, or he, is because my mom said so. Anybody else say fresh water? Caleb, what did you and Andre say?
Well, I think it's just how because in the thing that says about the boil point, it says when you add salt, it disrupts the bond between the water molecules, which means that like it can disrupt the boiling point.
So you're saying it because it's not. So are you saying it did that, and what happens to the boiling temperature of? So you think it lowers? So are you saying, you said fresh though? So you said fresh water, because fresh water is constant, right? Fresh water would always be 100 degrees.